Good afternoon, everyone, and once again, a very, very warm welcome on this cold winter day, which is very fortunate because I believe that your brain is super sharp in cold weather. And believe me, we're going to need that today because today we are going to look at two of the troublemakers in the chemistry paper. And the questions that we are going to look at we get from the National Senior Certificate Examination, November 2011. And the questions are question number 5 on page 7, which is on types of organic chemistry reactions. And the other question is question number 7 on page 11, which is about Le Chatelier's principle and the equilibrium constant. If you do not have the paper, you can get it from the WCED website under examination papers. It's there, so you can just get a copy. Now, let's have a look at question number 5, which is about types of chemical reactions, organic chemistry. Right, let's read the question. In the flow diagram below, R, P, and Q represent different types of reactions. There is R, P, and Q. And what we notice there, before we even do the question, is that that substance has got a double bond, which means that that is an alkene. It's just carbon and hydrogen with a double bond, so that is an alkene. This substance, they tell us, is an alcohol, and this substance is an alcohol. This substance consists of carbons and hydrogens and a single bromine. So in other words, we are dealing here with a haloalkane. Now, the types of reactions that we come across if we work with the haloalkanes and with the alkenes and with the alcohols, there are 3 types of reactions that gives us a lot of problems, and that is the addition reactions, substitution reactions, and elimination reactions. Look, you also get stuff like combustion, and but that is not what we're going to look at today. That is another day. But today we are going to look at these 3 reactions because they are the ones that are involved in this case. Because you can see in question number 5, they ask us for the types of the reactions represented by P, Q, and R, and so on. But I am going to explain it to you, what we've got here. If we look at, for instance, this is ethane. It's got 2 carbons, and it's ethane. And ethane is a saturated hydrocarbon for the simple reason that each one of the 4 valence electrons of carbon shares an electron pair with 4 different atoms. And that's why each one of the, let's call it arms, are occupied by a different atom, and it's full house. There isn't space to take in anything else. This is it. Now, this is a very unreactive type of substance. The alkynes do not react readily. There is one, however, and that is with the halogens. Now, do you remember what the halogens are? The halogens, that is in group 7, and that is fluorine, chlorine, bromine, and iodine, and so on. They are the halogens. Now, one thing that I just want to mention at this stage is that some people find it very difficult to remember what substances are what we call diatomic substances. In other words, the atoms, the element doesn't come in separate atoms. It comes in 2s, in diatomic molecules. Now, a very easy way to remember that is that, you know, if a person has had too much gin, he sees everything double. Now, all the elements that end on gin are double. Oxygen, nitrogen, hydrogen, and then all the halogens in group 7 or group 17, if you want to call it that, all the halogens They all are diatomic. You will remember that in future? Right, now let's look at the equation again. So I've got bromine, which is then a gin. It is a diatomic molecule. It contains 2 atoms. Now, the reaction that takes place between ethane and bromine, the only type of reaction that can occur here is that the bromine and any one of those hydrogens, let's pick that one, that hydrogen and this bromine, that they decide that they want to swap places. They want to exchange places. So in other words, the hydrogen is substituted by a bromine, and the bromine is substituted by a hydrogen. So what do we call this reaction? It is a substitution reaction. But please note, it could have been any one of those H's. I just picked that one because that's what happens to be. So I end up with a haloalkane and HBr. And it could be chlorine, HCl. It could have been chlorine, and then I end up with HCl or iodine or whatever. But let's just take bromine as an example. Right, the other halogens will do exactly the same. But what is now very, very important to notice about this reaction is this, that bromine is brown. Will you remember that? Bromine is a brown liquid. So what happens now is, if you would mix the brown bromine solution with any alkane, what happens is a substitution reaction is going to take place. One of the hydrogens is going to be replaced by a bromine, and because you don't have bromine anymore now, but now you've got HBr, which is colorless, the brown color of the bromine is going to disappear. So you can actually see from the fact that the brown color has disappeared that a reaction has taken place. And what is very, very important to remember about this reaction is that it's a very slow reaction. You can imagine this negotiation between the H and the Br. Shall we or shall we not exchange places? It's not so nice. Yes, it is nice. It takes some time. Negotiations take time. So therefore, it's a slow reaction. And in most cases, you will find that you will have to add energy, either in the form of, adding a little bit of heat, or you can even try ultraviolet light. That might also do the trick. But you will probably need to add a little bit of energy to get this reaction going. It's not a fast, easy reaction. You have to add energy. So please remember that a substitution reaction that takes place between a halogen and an alkane is a slow reaction. And what happens is that one of the hydrogens and one of the halogens, that they swap places and they are substituted. So that is a substitution reaction. This is now the first type that we are going to look at. The second type of chemical reaction that we are going to look at is then what we call an addition reaction. Now, what will happen with an addition reaction is that always happens when you've got an unsaturated hydrocarbon. This is now when the 2 carbons are bonded with a double or a triple bond, and that means that each carbon is just bonded to 3 other atoms. This carbon is bonded to 3 other atoms. So what happens now very easily in this case, a typical reaction that you will get when you deal with the unsaturated hydrocarbons is that this double bond breaks very easily. It just points, it breaks. Oh, this one is quite tough. And then there, you've got 2 arms available. So the double bond breaks, and there you've got 2 arms available. Now there must be something that is added there because it cannot exist like that. So what you can now add to this molecule at those 2 spaces that you've got there, the 2 arms, is that you can actually again use hydrogen, that is a diatomic molecule, and you just take those 2 H's and you add the 2 H's there. Right, so this is an addition. You added hydrogens to the molecule. The double bond breaks, and then you add the 2 hydrogens to the molecule. So I think it's quite obvious. What kind of reaction is this going to be? An addition reaction. Now, the addition of hydrogen can also be called hydrogenation. Hydrogenation. So you can call it, if they ask you what kind of reaction occurred here, you can say it's an addition reaction, or you may say that this is a hydrogenation reaction, the addition of hydrogen. Right, what are the other possibilities then? Now, once again, you can have the double bond, and then the double bond breaks, and now we can have a halogen that is added to the molecule. Now, once again, the halogen could be fluorine, bromine, chlorine, iodine, anything, but we are going to take bromine as an example. And now that double bond is broken, so now you've got those two arms available, and what's going to happen? Those two bromine atoms are just going to be added to the molecule, and then you call this an addition reaction. You can, if you want to, in more detail, say specifically that this is a halogenation reaction, because the addition of a halogen is halogenation. Or you can even go into more detail and say it is a bromination reaction. The addition of bromine to a molecule is bromination. What I want you to notice is that in an addition reaction, you will always find that the two atoms are added on both sides of where the double bond used to be. So they are on both sides on each one of those two carbon atoms, because each one of the carbon atoms will have an arm available. And if I can just pause maybe at this specific reaction a little bit. Once again, do you remember about bromine, what I said about bromine is brown? Right, so what happens in this case is that the bromine also reacts with the, in this case, the ethene, but this is now an addition reaction, but it has reacted, so the brown color is going to disappear. And if the brown color disappears, it means the reaction has taken place, and in this case, it's an addition reaction. But what is very interesting here is that the moment you mix the alkene and the bromine, it's instantly the reaction takes place. You don't have to do anything. You just mix them and voila, it happens. So what we can now look at that's very interesting is that if we compare, you remember what I said about the previous one where you had the saturated hydrocarbon. If you add bromine, then the brown color disappears, but it takes quite a time and you'll have to give it a little push with some energy and so on and so on. It's a slow reaction, whereas with a double bond, with the unsaturated, it's an instant reaction. And this is then what you can use as a test to determine whether a certain hydrocarbon is saturated or unsaturated. Suppose they give you two samples, A and B, and they say you have to distinguish which one is the saturated and which one is the unsaturated hydrocarbon. Then what you do with the two samples, you just mix it with bromine, and the one that discolors instantly, you can say for sure that that is going to be your unsaturated hydrocarbon, the one with a double bond, and the one that you have to heat a little bit before it's going to discolor the bromine, that will then be your saturated hydrocarbon. Please remember that this is what you can use as a test. Now, if we now go back to our addition reactions, what else can we have? All right, so we've got the double bond, all right, and say now we take HBr, a hydro, no, sorry, it's there, hydrogen halogen. We call that a hydrogen halogen. It could be HCl, HI, HF, but we are just going to take as an example HBr. The others will do exactly the same. So once again, what's happening here now is that double bond breaks, boing, it goes like that, and then these two atoms will sit on both sides of where the double bond used to be. So in other words, now I've got a alkane that's got one halogen. We call this reaction, this addition of a hydrogen halogen, we call that hydrogen halogenation. Hydrogen halogenation. You can also, if you want to go into more detail, say it's hydrogen bromination, or if it was chlorine, hydrogen chlorination. But this is then another type of addition reaction that you can come across. So what else is there? We can also have water. Now, if you've got water, in organic terms, water is HOH. Right, so you can also have the addition of water, which will then have an H adding there, and the OH adding there. And what do we call this substance? A hydrocarbon, but now it contains an OH group. That is classified as an alcohol. So now you've got an alcohol. The addition of water to an alcohol, or to an alkene, gives you an alcohol. This is then called hydration. The addition of water is called hydration. You know, if you want to be fancy, then you can also say, I am hydrating my garden. But hydrating means you adding water to something. So you are doing a hydration reaction here if you add water to this alkene. Right, so that is then the addition reaction that will occur when we've got a double bond. But now we get to something very interesting, and that is the third type of reaction. So we've had, so far now, we've had substitution reaction, which you get at the saturated hydrocarbons. Then we get addition reaction, which you get at the double bond, the unsaturated hydrocarbons, and you just add. But now we get to the third type, and that is now, if you understand the previous one, this one is so easy, because this one is exactly the reverse of what you've just done. And that is now, where in the previous one, you've added something to the molecule. What you're going to do now is you're going to remove something from the molecule. You're going to eliminate something from the molecule. Removal or elimination. And we call these reactions elimination reactions. Now, let's have a look at a few examples of elimination. Right. You remember that we've just said that if you add water, you call that hydration, and then the H goes there and the OH goes there. If we would now again remove a water molecule, if the addition of water was called hydration, the removal of water is called dehydration. You remember that if you would now go jogging on a very, very warm day, you might lose a lot of water through perspiration and so on. And then you can very easily become dehydrated. Dehydrated means you lose a lot of water. So in this case, if you remove water from a substance, you dehydrate it. If you add water, you hydrate it. If you remove the water, you dehydrate it. So this is then an elimination reaction, the removal of water, and that is called dehydration, if you remove water. Let's have a look at another one, another possibility of an elimination reaction. Suppose we have, previously we have added a hydrogen, halogen. You remember that was called hydrogen halogenation when I added them. If you would now remove a hydrogen and a halogen, you call that dehydrogen, and it will go back in a double bond. You will call that dehydrogen halogenation. The addition is hydrogen halogenation, the removal is dehydrogen halogenation. And once again, if you want to go into more details, you can say it's dehydrogen bromination, the removal of hydrogen and bromine more specifically. If you want to, for instance, say now you've got a molecule that contains 2 bromine atoms, and I hope you've noticed that the removal will always come from 2 neighboring carbon atoms. It's impossible to have it from 2 distant carbon atoms because they have to form a double bond between them with those 2 open arms that remain once you've removed that. So the addition of bromine or of a halogen was called halogenation, or the addition of bromine was called bromination, but the removal of bromine from the molecule will then be called dehalogenation or debromination. And then the last one that we can look at maybe is if you have, do you remember right at the beginning? When you add hydrogen, it is called hydrogenation. If you would now remove hydrogen, it's called dehydrogenation. Dehydrogenation. So in other words, the three types of reactions that we are going to look at is then substitution, where the H and the bromine just exchange places. We have addition, where the double bond breaks, and it's got two arms available where you can add anything, right? That's an addition reaction. And then the third type is where you've got a molecule, but now you remove two neighboring molecules, atoms from them, and that removal is called elimination.